In this session, we will try to continue to uncover strings in Java. Let's see the difference between double equals and dot equals method. Double equals is meant for reference comparison. It returns true if two objects are pointing to same reference, else it returns false. Dot equals method is meant for content comparison. If it returns true if two objects are having same content, else false. Double equal to is an operator which is used in primitives and objects. Dot equals is method which is used only for objects. We will see different examples. So first, let's take a simple example. Let's say string S1 is equal to new string of say Java. And then let's say we have another string called S2, new string Java again. And we have another string S3. This time let's take uppercase J. So for example, if S1 is equal to S2, let's see what it returns, and S1 is equal to S3. Also, let's try to use the equals method of S2 and then S1 equals S3. So first, string S1 is Java then string s2 will create another object with Java, then string s3 will also create another object with an uppercase here. So, like we discussed, double equals to will try to compare the reference. So S1 is equal to S2, which is false because these are two different references. So we will get a false here, and then string S1 is equal to S3, which is also false, and string S1 dot equals method S2, as we discussed, it will compare the contents. So it is lowercase Java, S2 is also lowercase Java, this will return a true. And string S1 is lowercase Java, S3 is an uppercase Java, this will return a false. So let's try to run this to see if we are getting the same result. Compile, execute. So false, false, true, and false. Now let's move on. In Java, all the strings are divided into four types. One, Java dot lang dot uppercase string. Two, Java dot lang dot string buffer. Three, Java dot lang dot string builder. Four, Java dot lang dot string tokenizer. So let's first explore the first one, Java dot lang dot string class. If the content is fixed and never changes, then we should go for string class. It is immutable and modifications are not allowed. So let's explore constructors. in the string buffer in the string class. So the first constructor is string s equal to new empty string. Then next one is string literal, in other words, constant. Then we can also use a character array, and we can also use an offset with count. Next one is we can take a byte array, and also we can use an offset with the size. The next one is a string buffer. Next one is string builder. Let's uncover each of these. So the first one, so let's say string s equal to new empty string, and let's try to print s. So this will be an empty string, and then let's say, for example, length of the string. Then let's also say s dot is empty. Is empty, it's gonna be true. Length of the string is 0 because we are using an empty string. Let's try to compile and run this. So you will not see the empty string. The size length is 0 and it's an empty string, so it's true. Now let's look at the next constructor, which is string literal. For example, if I'm just taking Python, if I print it, I should see Python here. If I print the length, I should see 6. And is it empty? It's going to be false. Let's try to compile. Execute. Also remember, if we declare a string s equal to and assign the string directly, it's gonna save it temporarily in SE. But if we declare string s equal to new string of Python, then it's gonna save it permanently in the heap. Let's look at the next constructor, which is a character array. So for example, if I have a character array, ch is equal to, let's say, w, comma, e, comma, l, comma, c, comma, o, comma, m, comma, e. And then let me write down the positions of this array: 0, 1, 2, 3, 4, 5, 6. So for example, if I assign string s is equal to new string and assign the array here, and if I try to print string s, it's gonna print welcome. Let me compile. Let's look at the next constructor. The reason I have written positions here is to see how it works while using offsets. So for example, if I have string s1 is equal to new string of character array ch, and if I have string ch3 comma 4, and let's say for example if I have 0 comma 2, and then let's say if I have 5 comma 2, and let's try to print each of these strings: s1, s2, s3, and s4, and s1, s2, s3, s4. First one will print the entire string, which is welcome. The second one will print from position 3, and the size should be 4. From position 3, and size is 1, 2, 3, 4, which is until 6. So the second one print come. And the third one 0 to length 3, length 2. So we should see not position but length. So we should see a V here. And from position 5, length 2, that's going to be ME. Let's try to execute. See, welcome, come, we, me. Let's move on and see next constructor, which is string s equal to new string byte array. It converts the given byte array into string by using platform's default character set. We'll see what that means in a minute. So for example, if I have a byte array, say 65, 66, 67, 68, 97, 98, 99, 100, 48, 49. So the positions will be 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, for example, what is the string equivalent for 97? What is the string equivalent for 65? That's going to be uppercase A. I mean, character equivalent for 65. And then what is the character equivalent for 48? That's going to be 0. Now, let's try to print the string S1 is equal to B. Let's try to compile, execute what this returns. String S1.
What? What toaster? No.
I have not changed the variable name to be. Compile, execute. So this is the result. We print the byte array. Now, let's use the offset for this. So convert the given pi from given offset value into grid.
What? Yeah. Okay. Do you want a thumbstick?
So let's say if string S1 is B and then string S2 is B 0 to 4, then string S3 is 4 comma 4 and string S4 is 8
Green.
to size 2. So this is gonna return print all the strings S1, S2, S3, and S4. So the first one will print the entire character string. Second one will print from position 4
Girl, I'm doing every round. Because this.
string S1 will print entire character string. S2 position 4 till the next 4 positions. So 1, 2, 3, 4. So this is S2 is 0 to 4. So 0 and we have 4. So S2 will print A, B, C, D uppercase. Then from 4 we have 4 positions, so it's gonna print lowercase a, b, c, d. Then for string S4 from 8, 2 positions, so the last 2, which will be 0 and 1. Let's try to compile. Execute. Now let's look at the next one, which is string buffer. Say, for example, I have string buffer fb is equal to new string buffer is John. And string s is equal to new string sv. Let's print sb. It should print John. And let's print as it should print John. However, this string builder is mutable, but this John or string is immutable. Let's try to compile. Execute. Like I said, you'll not see the difference, but one is mutable, the second one is immutable. The last one is string builder. What is the difference between string buffer and string builder? String buffer, we allow only single thread, no multi-threading, but string builder SP string builder John, it is multiple threads is allowed for builder. Here it is single thread. And the output will look the same. So far we have uncovered constructors in string class. Now let's move on and see methods in class. First one is int of length. So let's say we have string s is equal to say hello. And if I print s, it's going to obviously print hello. And if I print s dot length, it's going to print 5. Let's compile and execute. The next one is Boolean and is empty method. So the first one is string, let's say s1, hello, and string s2, let's take it as an empty string. And let's try to check s dot s1 dot is empty. It's not. So it's gonna be false. And let's check it for s2, which is an empty string. It should return true. Compile, execute. The first one is false, the second one is true.